وعلى آله وصحبه أجمعين. This is a continuation of section 3.1, and today we will talk about percentiles and quartiles. At the end, we will talk about the box plot. So let us start by percentiles. The pth percentile in a data array means sorted data. So to calculate the percentiles or the quartiles, you need to sort the data first, similar to the median. P% are less than or equal to the pth percentile, and 100 minus P% are greater than or equal to this value. So, for example, if I talk about P30, the 30th percentile, then P%, which is 30% of the data, lies to the left, less than means to the left, and 100 minus 30, which is 70% of the data, lies to the right. So this is the definition of the 30th percentile, and you can define 99 percentiles similarly. So here I have P1, the first percentile, in which 1% of the data lies to the left and 99% of the data lies to the right. Then I have P2, the second percentile, where 2% of the data lies to the left. So 1% between P1 and P2, and 1% to the left of P1. And 89% of the data lies to the right of P2. Then I have the third percentile, 1% here. So 3% lies to the left of the third percentile, and 79% lies to the right. At the end, I have, there should be no question, please. I have P199, the 99th percentile, 1% of the data lies to the right, and 99% lies to the left. Okay, I have here P98, the 98th percentile, 2% lies to the right, and 98% lies to the left. So this is the idea of percentiles. The 50th percentile is the median, because we know that 50% of the data lies to the left of the median and 50% lies to the right of the median. And this is exactly the definition of the 50th percentile. So the median, MD, is in fact P50, the 50th percentile. Also, the quartiles. Also, we have 3 quartiles in the data. We have Q1, which is the P25, 25th percentile. And then we have Q2, which is the median or the 50th percentile. And then I have Q3, the third quartile or the upper quartile. And this is the 75th percentile. So what is the definition of the 75th percentile? 75% of the data lies to the left and 25% lies to the right. What is the definition of the 25th percentile? 25% lies to the left and 27% lies to the right. What is the definition of the 50th percentile? 25% lies to the left. So 25% here, 25% here, 25% here, and 25% here. So the 3 quartiles divide the data into 4 equal regions. Equal means we have 25% of the data in each of these 4 regions. How to calculate percentiles? We simply sort the data first and determine the location index, and then we go to the appropriate place to choose or to determine the percentile. So let us figure out what is the location index, I. This is similar to the median, the steps used to locate the median. This is the percentile location index. it is P over 100, where P is the desired percent. So 10th percentile, P would be 10. 50th percentile, P would be 50. And N, the number of all the values in the data. Let us take an example. I have data with 309 values. Okay, 309 customers here enter store during the course of a day. Anyway, what is the question? I need to determine the 10th percentile of the 309 data. So the first step is to sort this data. And then I find the index. The location index would be, I need the 10th. So P is 10 divided by 100 multiplied by 309, which is the N, small n. I get 30.9. Okay, what happens after I evaluate the index? Now, if the index is not an integer, which is the case here, 30.9 is not an integer, you round up to the next higher integer. Okay, so I would be 31. So I would be 31. So the 10th percentile, P10, would be in the 31st position. Okay, 31st position. So if you order the data number, value number 31 is the 10th percentile for any 309 values. For any 309 values, the 10th percentile would be always the value in the 31st position. What happens if I is an integer? If the answer is 20, for example, if I is 20, then you have to take the average of the values in position I and position I plus 1. Okay, that's the case. So here, this is the solution. I 30.9, it is not an integer. You round it up to 31. So the value in the 31st position would be the 10th percentile. Let us take an example. Determine the 80th percentile. Well, how many data I have here? 3 times 10, I have 30 values. Now, sort the data. I need to sort the data. And then I need to determine the index. So the index, I, is 80th percentile. So P is 80 over 100 times 30. This would give you 24. It is an integer. So the 80th percentile would be in the position between 24 and 25. So I need to sort the data and find the position, the value in the position 24 and the value in the position 25. So I can sort the data. This is position 1, position 2, and so on. Okay, this would be position 30, position 29, position 28, position 27, position 26, position 25, position 24. I need the number which is here between position 24 and 25. I can arrange starting from the largest because I need just to know to answer this question, what is the 80th percentile? So I'm not really interested of sorting the data from the lowest. So the highest is 26.9. And then I have 24.9. There is 23.7. 21.7, 21.4, 21, and there is 20.5. This is what I need. There is no need to continue sorting. For the 80th percentile, which we call it P80, is equal to the average between 20.5, which is the value in the 24th position, plus the value in the 24th position and the value in the 25th position. So If you add divide by 2, the answer is 20.75. So this is the 80th percentile of this data. What does it mean? It means 20% of the data lies to the right of this number, and 80% of the data lies to the left of this number. Another example, the ages of 15 employees selected from a company are as follows. Calculate the mean, median, first quartile, and the third quartile. Well, for the mean, he said selected for, okay, I'll deal with it as a sample. فالX bar is you add all the numbers and divide by 15, okay? And you write the answer. You add all the numbers, 53 plus to 41, and then you divide. That's the mean. We know how to do it. Please, you can do it easily, okay, and get the answer here. Now let us concentrate on the median, first quartile, and the third quartile. To find these three measures, I need to arrange, to sort the data. So I will sort the data from the smallest. I believe that the smallest is 25, okay. Then 27, then 28, okay. Then I have 32, 33, 33, 35, 36, 39, any other 30. Okay, then I have 41, 44, 45, any other 40. Okay, 53, 57, and 61. Let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I have 15 numbers. Good. So these are the data sorted. Now, to find the median is the index of the median, if you remember, 15 divided by 2, 7.5. So I go to the 8th position. 8. So the median would be, the median is of course the 50th percentile. It is also the second quartile, okay. Number 8, this is number 8. So 36 is the median. If you check your answer, you will find that 2, 4, 6, 7 numbers to the right and 7 numbers to the left. Good. So after the median, I need to find the first quartile. The first quartile is Q1, which is P25, the 25th percentile. So to find Q1, I need to find the index. The index is 25th percentile, so 25 divided by 100 times 15. If you calculate 25 divided by 100 times 15, you get 3.75. This is not an integer, you round up to 4. So Q1, or the 25th percentile, would be the number in the 4th position, which is 32. Now, the third quartile, 75, it is the 75th percentile, the 75 over 100 times 15. It is 11.25. It is not an integer. I round up to 12. So the position of Q3, which is the 75th percentile, is the 12th position, the number in the 12th position, which is 45. So these numbers, 32, 36, and 45, are the 3 quartiles, and they divide the data into 4 regions. In each of these 4 regions, you have 25% of the data. So if you remove these 3 numbers, the 3 quartiles from the data, you have 12 remaining numbers. You will find 3 numbers, as you can see, between each 2 quartiles. So they divide the data like this. These are the 3 quartiles. Notice something very important. Now, Q1 is 32. Q2 is 36. Q3 is 45. So if you put them on a number line, okay, if you say this is 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45. Then 32, this is Q1. 36, this is Q2. And 45, this is Q3. Now, if you draw a rectangle here, this rectangle is called box. So we will talk about box and plot in 10 minutes, maybe less. So notice something important. Q2 is not in the middle. Okay, Q2 is not in the middle between Q1 and Q3. It's not necessarily in the middle. It could be to the right, it could be to the left, it could be in the middle, and this would give you something about the distribution of the data. Okay, we'll talk about it later. What is the distribution of the data in this case? But this is an important point. Although there are 25% of the data between Q2 and Q3, between 36 and 45, there are 3 numbers. Between 32 and 36, there are 3 numbers. So the same number here, same percentage of the data here, same percentage of the data here, but Q2 is not in the middle. So you need to understand this fact. Another example, consider the following data that represent the commute distance for students who attend a certain college. Okay, these numbers are sorted, alhamdulillah. So this is number 1, 2, 3, 4. You can count the data 5, 6, 7, 8th position. These are the positions. 10th position, 11. So the number in the 13th position is 28.6. 15th position, 31.4. 18th position, 40.9. Okay, so these are the positions of the data. How to determine the 20th percentile? The index is 20, P is 20, divided by 100 times the number of the values in the data. We have 20 numbers. So if you multiply, you get 4. Good. 4 is not an integer. So you go to 4.5. Okay, you go to 4.5. Or P20 would be the average between the number in the 4th position and the number in the 5th position. It should be here in the middle between the number in the 4th position, which is 13.2, and the number in the 5th position, which is 14. If you divide by 2, you will get 13.6, and that's the 20th percentile for this data. To determine the 25th percentile, the 75th percentile, I leave this for you. It is similar. This is Q1 and Q3. You do exactly like here, Q1 and Q3. And also to determine the number of the median, I leave it for you. I solved it already. A question like here, the data was not ordered, while the data here is ordered. So it should be easy for you to evaluate. The first quartile, find the first quartile in an ordered array of 19th values. So n is 19. If you need the first quartile, that's the 25th percentile. So this is 25th percentile. So you divide 25 by 100 times 19, 4.75. It is not an integer. You round it up. You take the value at the fifth position. 1, 2, 3, 4, 5. The value in the fifth position is 51. So the first quartile is 51. And you can practice by yourself how to find the median and the third quartile for this data. If the data is sorted, if I can find it easily, okay, how? Look to this method. I have four numbers here. For 1, 2, 3, 4, this should be the median. 1, 2, 3, 4, this should be Q3. 1, 2, 3, 4. So this is Q1, this is the median, this is Q3. طبعا check by calculation and no, your answer is correct, but this must be the correct answers because we know that 25% should be here, 25% should be here, 25% here. So these are the three quartiles. Let us go now to the Box and Whisker plot, and please pay attention to it. We need the quartiles to graph the Box and Whisker plot. It's a graph which is composed of two parts, Box and Whiskers. The Box, as I mentioned to you earlier, has a width that ranges from the first quartile to the third quartile, and a vertical line through the box is placed at the median. So as I told you, I have box like this in which Q1 is here, Q3 is here, and the Q2 is somewhere here or here, whatever. I don't know where is Q2. It should be, it could be anywhere in the middle or not. But this is called the box. Okay. Now how to determine the whisker? The whiskers are dashed lines coming out from the box. So to determine these whiskers, I need to determine a lower and upper limits. This is lower limit, and this is upper limit. So how to determine the limits? The limits are calculated at a value that's 1.5 multiplied by the difference between Q1 and Q3 below Q1. Okay, so the lower limit is calculated. It is below Q1. It is to the left of Q1, as you see here. It's Q1 minus what? Minus a distance. What is this distance? It is 1.5 multiplied by the difference between Q3 and Q1. So this is the lower limit. The upper limit is to the right of Q3. So above Q3. So you add Q3 plus the same amount, 1.5 times Q3 minus Q1. They call Q3 minus Q1, it is called interquartile range. It is denoted by IQR. So you can say that the upper limit is Q3 plus 1.5 times IQR, the interquartile range. What is the interquartile range? It is Q3 minus Q1. So for example, in this question, what is IQR? It is Q3 minus Q1. Q3 is 88, Q1 is 51. So this number is called the interquartile range. It is the range 37 that contains 50% of the data. 50% of the data are from 51 to 88. So this is the range of 50% of the data. The range of all the data, if you want to find the range would be 97 minus 36. So the range in general, this would be defined in the next section, inshallah. It is 97 minus 36. This is the range in general of the data. The range of the data is 61. And the range helps you to find the variability, whether the data is how much variable is the data, the variability, the spread of the data. Okay, so the interquartile range for this data is 37, the range is 61. For the box plot, we use the interquartile range, we multiply it by 1.5, we subtract from Q1 to find the lower limits, we add to Q3 to find the upper limit. And after you find the lower limit and the upper limit, you can draw the whiskers. You extend the whiskers from the left, from here, you go to the left, from the box to the left, to the lowest value within the limits. So the lowest value within the limits. So if the limit, for example, is 20, what is the number greater than 20 in the data? 21, so you take the whisker to 21. But if there is 19 in the data, you don't take the whisker after the lower limit. The whisker shouldn't go beyond the lower limit or the upper limit. So it stops before the lower limit and it stops here before the upper limit. You choose the highest value within the limit and you go to the right to that highest value within the limits. Let us take an example and please pay attention to the example. First, let us sort the steps or write the steps. We sort the data. We find Q1, Q2, and Q3, and then we draw the box. The box which is from Q1 to Q3, where Q2 is somewhere here. So this is step 3. And then we draw a vertical line. This is the median, okay? And then we calculate the interquartile range, and then we find lower limits and upper limits. And then we draw here the lower limits and the upper limits. And then we extend dashed lines, the whisker, to from each end to the highest and lowest values within the limits. If there are numbers in the data that are to the right of the upper limit or to the left of the lower limit, we call them outliers, and we put asterisks in their places. Okay, let us take this example. Here, the question is construct a box and whisker plot. I have this data. I have numbers sorted. Alhamdulillah, the data are sorted, so you don't have to sort them. So sorting the data, it is already sorted. Calculate the 3 quartiles as we learned. This is the first quartile, okay. It is 250. And the second quartile, the median, this is Q1. The median is 259. And Q3, the third quartile, is 266. So you go to the data. You need to draw a line like this. And you need to choose a unit of measure suitable. You need to look to the data. What is the smallest number? It is 231. What is the largest? It's 345. So you usually start from below 231. You could start from 200 if you like, and you go to above 345. You could go to 400 if you like, and you can choose 10 as a unit of measure, because 200 to 400, or choose 20. It is up to you. And then you put Q1, okay? So what is Q1? Q1 is 250. So above 250, you draw Q1, and Q3 above 266. So this is 266. So above Q3, above 266, this is Q3. And then you put Q2 between them. So Q2 is 259. So this is 259. You go up at 259 here. So this is Q2. So notice Q2 is not in the middle between Q1 and Q3. Now this is the box. That's excellent. Now you need to determine the whiskers. And to draw the whiskers, you need first to find the lower limit and the upper limit. And this is the lower limit. This is the formula. Q1 minus 1.5 times Q3 minus Q1. So you use the formula. The lower limit is 226. So now I don't have, that's why you need to start from 220 and you draw the lower limit. This is the lower limit, okay? And the upper limit. This is the formula of the upper limit. You put the numbers, find the answer, 290. So this is the upper limit. It would be here, 290. Good. Now you have the lower limit, 226. You have the upper limit, 290. How to draw the whiskers? Please pay attention to this point. Now you go to the data. Look to the data. I need the first number greater than 226. What is the first number in the data which is greater than 226? It is the first one, 231. Okay, so 231, this number should be 231. So I go from the whisker, from the box to 231. This would be the left whisker. How to determine the right whisker? Look to the upper limit. What is the upper limit? 290. I need a number in the data, the highest number in the data, before 290, less than 290. Go to the data. 290. Search. This is 286. After that, 300. So 290 is here. 286 is less than 290. It is the highest number, less than 290. So I find 286 and I take the whisker, the dashed line, from the box to 286. So this is how we draw the whiskers. So the whiskers should not go beyond, should not intersect with the lower limit or the upper limit. Now I ask myself a question. Are there values in the data less than 226? No, 226 is smaller than all the data. Is there any value in the data greater than 290? Yes, there are three numbers in the data greater than 290, 300, 324, 345. So at 300, I put a star like this, okay, or we call it asterisk. I put an asterisk here, and above 325, I put an asterisk, and I put 345 above it, I put another asterisk, and I have three outliers. There are three outliers in this data. I stop here, and next time we take another example about the box plot. I open the floor.